Okay, Waka, so we're at journal page 55, understanding geometric sequences. In a geometric sequence, the ratio of the successive terms is constant. The constant ratio is called the common ratio. Let's take a look at the first example. All right, find the common ratio R for the geometric sequence and use R to find the next three terms. So this one's pretty simple. You can see that we're multiplying by 3. So 4 times 3 is 12. 12 times 3 is 36. So 36 times, so let's double check with the calculator, but pretty simple. 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. So we can see the common ratio is 3. So to find the next three terms, we're going to take 108 times 3 is 324. You can highlight, enter, times 3 is 972. And then highlight, enter, times 3 is 2,916. All right, let's take a look at the next example. All right, find the common ratio of R for the geometric sequence and use R to find the next two terms. So pretty straightforward. Looks like we're multiplying by -3, but let's double check. Let's remove the previous problem. So -4 times -3 is 12. 12 times -3 is -36. -36 times -3 is 108. So our common ratio is -3. All right, so to find the next three terms, we're just going to multiply by -3. So 108 times -3 is -324. Highlight, enter, times -3 is 972. Highlight, enter, times -3 is -2916. All right, go ahead and finish up that example. All right, let's take a look at the next example. All right, example 4. Find the common ratio R for the geometric sequence and use R to find the next three terms. Okay, another way to find the common ratio is to do this. Okay, let's remove the previous problem. So we're going to do 16 divided by 32, 8 divided by 16, and 4 divided by 8. So you can see the common ratio is 1/2. Okay, so to find the next three terms, multiplying by 1/2 is the same as dividing by 2. So we can do 4 divided by 2 is 2. 2 divided by 2 is 1. And then 1 divided by 2 is 1/2. All right, so the next three terms are 2, 1, and 1/2. Let's take a look at the next example. All right, find the common ratio R for the geometric sequence. Use R to find the next three terms. Enter your answer to 4 decimal places. Okay, so we're going to go to our calculator. Let's remove the previous problem. All right, so now we're going to do -120 divided by 300. And let's go ahead and press Control Enter to go straight to the decimal. Okay, so then we're going to do 48 divided by -120, Control Enter, and then -19.2 divided by 48, Control Enter. So you can see that our common ratio is -0.4. Okay, so to find the next three terms, we're going to multiply -19 0.2 times negative 0.4, so 7.68. Highlight, enter, times negative 0.4 is negative 3.072. Highlight, enter, times negative 0.4 is 1.2288. All right, go ahead and finish up example 6. Let's take a look at the next example. All right, find the common ratio R for the geometric sequence and use R to find the next three terms. Okay, so let's go to the calculator. We're going to remove our previous problem, and we're going to do 2.16 divided by, oh, wait, I'm sorry, 3.6 divided by 6, control enter, 2.16 divided by 3.6, control enter, and 1.296 divided by 2.16, control enter. So you can see the common ratio is 0.6. So to find the next three terms, we're going to multiply 1.296 times 0.6, control enter, is 0.7776. And then we're going to highlight, enter, times 0.6 is 0.46656. And then we're going to highlight, enter, times 0.6 is 0.279936. All right, go ahead and finish up example 7. All right, example 8. Find the indicated term of the sequence by repeating multiplying the first term by the common ratio. So this one's pretty simple. The first term is 7. I'm sorry, the first term is 1. Second term is 7. Third term is 49. And you can see we're multiplying by 7. So the fourth term, we need to multiply by 49. So let's go to our calculator. 49 times 7 is 343. And so then the fifth term, we multiply 343 times 7 is 2,401. So the fifth term is 2,401. All right, go ahead and finish up that example. All right, let's take a look at the next one. Find the indicated term of each sequence by repeating and multiplying the first term by the common ratio. Enter your answer to the 7th decimal place if necessary. So we need to go to the 7th decimal place if necessary. So first term is 16. Second term is negative 9.6. Third term is 5.76. So we need to go to the 7th term. Okay, so let's go ahead and use our calculator. Let's find the common ratio first. So negative 9.6 divided by 16, control enter, and then 5.76 divided by negative 9.6, control enter. So our common ratio is negative 0.6. So we need to multiply 5.76 times negative 0.6 is negative 3.456. Fifth term, we're going to highlight, enter, times negative 0.6 is 2.0736 times negative 0.6 is negative 1.24416, and the seventh term times negative 0.6 is 0.746496. All right, so the seventh term is 0.746496. All right, go ahead and finish up that example. Find the indicated term of the sequence by repeating multiplying the first term by the common ratio. Use a calculator. All right, so first term is 5, second term is negative 10, third term is 20. This one's easy. We're just multiplying by negative 2. So fourth term is negative 40. Fifth term is a positive 80. And then the sixth term is negative 160. Okay, so the sixth term of the sequence is negative 160. All right, let's take a look at the next example. All right, a ball is dropped from a height of 800 centimeters. The table shows the height of each bounce. The height from the geometric sequence. How high does the ball bounce on the fourth bounce? So we're looking for the fourth bounce right here. So we need to find the common ratio. All right, let's remove the previous problem. So we're going to do 490 divided by 700. Control Enter. And then 343 divided by 490. Control Enter. We can see the common ratio is 0.7. So all we need to do is multiply 343 times 0.7, and that's 240.1. So the ball bounced 240.1 centimeters on the fourth bounce. All right, let's take a look at the last example. All right, a biologist studying ants started on day 1 with a population of 1,500 ants. On day 2, there were 3,000 ants, and on day 3, there were 6,000 ants. The increase in an ant population can be represented using a geometric sequence. What is the ant population on day 6? So pretty simple. Day 1, there was 1,500 ants. Day 2, there were 3,000 ants. Day 3, there were 6,000 ants. So day 4, pretty simple. We're multiplying by 2, so that's 12,000 ants. Day 5, there was 24,000 ants. And day 6, there were 48,000 ants. Okay, go ahead and finish up your example, start working on your assignment, and have a wonderful Wildcat day.